Hello everyone, this is the second video about how to use DIMS to perform DBA SQL Server administration task. Today we'll continue from the points that we left last time when we discussed GUI, and I would like to speak about the operations or advanced operations that you can do with the result set. I will just execute some scripts. I am executing these scripts in order to have the input data that I will use in the example that will follow. I spoke last time about the related scripts. This is a feature that will allow you to execute scripts which are related with the main script that you just executed. For example, if we will check which related scripts we have for get running traces, we see that we have scripts like check if the trace is expensive and query the trace file. For example, I would like to query this trace file to see the data in it. And we have an option here. For example, if I'm clicking on a cell here, I can retrieve count for the selected cell or retrieve count for all selected cell from the current result set and from the all result set. This is a feature that will allow me to see if on another server I have the same login performing different type of activities. For example, let's suppose that we have a production and a development server, and we are using a similar login on each of them, and we want to see if they perform the same kind of activities and what are the differences between those activities in the query trace, in the trace file. For example, let's start the second SQL server. Zero one and I will choose to execute not to wait for delay. I will execute trace files, a script that will give me access to execute the querying of the trace file. This script, for example, if we see that a server is running slow, we can always assume that maybe somebody is configuring or is running some traces which put a load on the SQL server. But okay, finish with error and messages. Maybe the SQL server was not found. Let me find that if I put mess SQL server 01 services. I didn't start the service. I will start it again. I just changed the startup type. We'll execute the script again. Yes. And we'll just query the trace file. And we have here this login. Of course, I'm using the same login to connect, but in order to just demonstrate the purpose of this feature, let's suppose that we run these scripts against the production server and also against the development server or UAT server, and we want to see if this login appears in both of them. So retrieve count for all selected cell from current result set, no, from all result sets. For selected cell from all result sets. And we will see that we found that value in this script that was run against the DIMS instance in separate logins in query trace file and also in query trace files for this. This is meaningful because it gives you the possibility to search for similarities between servers when you are searching for a login or for a database or for an activity. I will come back to this feature a little bit later. For the time being, I want to explain about the advanced result sets capabilities. Here we can see that we can perform more aggregations on the result set that we retrieve from the SQL Server from executing a PowerShell script. I will not speak about the pivot with no aggregation because I already covered this in the last video, and I will not speak about count min max sum average and also about count min max sum average window because these were covered as part of these aggregations here. If we go back here and if we go in the main result set for aggregation, we can see here that for this result set we can obtain aggregations for different columns grouped by different columns. So I will not cover this, and I will not cover them here because they are doing almost the same thing but in a different manner. But I will try to cover pivot with aggregation. I will try to cover time window, get inflection points, union, intersect, except, and join columns for. So I'll try to cover all the other options that are available here, which will give more meaning to the data that you just retrieve from the SQL Server. So let's start with pivot with aggregation. We can take this result set, put it here, and let's suppose that this is exactly what Excel is doing, but I let's say took that possibility from Excel, and you can do some aggregations and you can do pivot from this application. You don't need to copy this in Excel and do this in Excel. Actually, I can try to copy just to see how it will look like. Control C. Control V, insert pivot table, all data, and we want to put as rows, we'll put database name. Database name as columns, we'll put host name, and as values we can put speeds, and we have some of speed, and this is the information that we obtain. Let's go back to the application and let's try to duplicate this behavior. This is not a good result set to describe this feature. We will use a different result set, but for the time being, because it's easier and it's a smaller result set, we will use this as an example. And so we will put DB name as rows, DB name as rows. We will choose host name as column, and we will choose speed as values, sum. Okay, this is the output. Sum of speed 69, grand total, blank master, 761, 210, 971, total 69, sum of speed, so although it's a little bit different than what you see in Excel, this allows me to do some aggregation using the pivot feature. So for sometimes it's good to have this, and you don't need to just take data from one tool and put it in another tool, do computations in that tool, after which you will copy the data from that tool and share it via Outlook or email. So I just wanted to have this possibility here. To exemplify this pivot feature better, I will use a different result set. Let's use a server repository. We retrieve data from the server repository. We go to advanced result tab, and here we'll load this. Because server repository, we are still, whenever we are not choosing a server for our script execution, it will be use the server that was the last entered here. Because on this instance we don't have that table there, the script fails. So I have to choose the proper instance. I'll choose again server repository, and I will execute the script again. Okay, we have the script here. We'll load it, and let's try to do a pivot here. I am more used to use this table. So for example, let's suppose that for this we'll use as rows the domain. We'll use as rows the domain. The domain will use the release. For example, we want to know what kind of SQL Server releases we have on each domain. So let's use release also. Okay, and as column, we would like to see, based on the domain and the release, what the type of backup product is used. And we want to see exactly the number of servers for which are having this as backup product, and in each domain and for each release. So for the values, we'll use the server name. And we'll choose the count. So we can see here the options that we have, and you can see the information. If we'll put this in Excel, it will yield the same information. It's displayed differently, but the purpose is the same. If we want, we can also collapse like Excel does. But for exemplification, maybe let's copy the data and let's try to put it in Excel. Okay. Control C. I will open another Excel file. Blank. Let's paste this data. we'll insert pivot for all the rows and all the columns, and we'll try to duplicate what we did in the GUI in DIMS. So we choose the domain, we choose release, we choose for rows, we choose domain, for rows we choose release for already put it, okay, release for this for rows. As columns we use the backup product, and as values you use the server name with a count. So this is the output in Excel, and this is the output in application. I will try to see if I can fit both of them in the same screen. But for AM domain, we have for 2012 release, we have one, which it's also here in our output. I guess that Excel it's offering the possibility to collapse and expand this information. So I tried to duplicate this, and let's collapse the EU dev domain. As you can see, 445, 184, 21, and 250. If we collapse the EU first domain bus, 411. Okay, I believe this is enough for this feature, but sometimes for specific results that you just want to compute the data and maybe share it with somebody. So in case I want to share it with somebody, I need to, when I'm copying it, I need to apply a different type of logic, because I cannot share with somebody this kind of column headers, but this requires more more work, but it gives you the it does the job which was supposed to do, which was the pivot with aggregation. If I try to copy this, for example, Control C by default without choosing to copy as tabular, let's see what will be the displayed output. I never tried it because when I created this feature, I was never planning to copy the data, or at least, of course, I was planning to copy the data, but I never worked to see how I should copy the data and how it will be displayed. But for the time being, let me see how it displayed. So, okay, maybe I needed to do some work in renaming these column names. Let's see how Excel is saving the data. So for example, let's suppose that I want to copy something similar to this. Control C. And note that it's a little bit different, but yeah, with a little bit of work, we can duplicate and display it almost identical. Of course, one thing to notice while working on this, when I was using Excel with a huge result set, the results and aggregation were almost instantly. But when I was using GUI, I had to wait for those for the computation to take place. So when it comes to the performance, you cannot compare it. As I said, I will repeat it again. This was created for metadata and for small result sets. I don't know, up to 5,000 rows or something like that. But usually for the companies that I worked for, you can, when it comes to server repositories and the real estate that they have for SQL servers is under 2000 instances or 3000 instances, so you have 3000 rows, but you can always optimize this. I believe this feature was covered enough. The other feature that I want to cover from here is count min, max, sum, and average time window. I will use the same result set because this is a good result set since it has a create date column and our feature covers the time window. So for example, let's suppose that somebody will say not somebody, you will try to see, I would like to see how many servers were installed in the last month, or how many servers were installed in specific time window. So we will choose this option. Let's collapse this back. We'll choose time window. I will choose the interval, and the interval will see it will be 1 day. Results that contain columns that will affect the accuracy of the computed data. Does not contain unique values. Column server instance does not contain. So with this result set, we cannot use this feature, but I have another result set which allows me to use these features. If you see here, wait for delay. This is I will load it here. This is a result set which contains information about the SQL Server counters retrieved from the servers. This is just an example, but you might have a data warehouse in which a database team is retrieving different performance counters for all the SQL servers, and you want to consume this the data in this table. Okay, so we'll see it's from 28 February. Let's see. So this is only like 2 days, 2 days or 3 days data. Let's suppose that we want to see the aggregate information for 6 hour interval. Doesn't contain unique values. Let's make unique values here. We should use unique values. We'll go back to wait for delay. Go back to the script, and this is, we'll load wait for delay. We'll filter the table to give us only the rows for a specific server. We'll copy this data, Control C, and we'll choose this feature of populating a new table with the data which is in clipboard. So we'll just paste it, and as you can see here, we have another script which was just populated with this data. So we are going back to the advanced result set control, and we will try to use the new data that we have. We will just populate it here. And let's try to use again the time window for this data set, for this table. So we choose the interval 6 hours. Collection time of 554, 550, okay, and we'll use as aggregation 1 hour, and here we can see the computed aggregation for all the columns for this interval. If we go here, you will see that the timestamp is from 8 p.m. to 9 p.m., from 9 p.m. to 10 p.m. So sometimes when you have this type of result set and you want to have specific aggregations done, you don't need to rewrite a T-SQL script that will retrieve the data and give you the data in this format, which will take obviously more time, or if you have it already written, you still need to have time to take it, copy, paste it in a SQL Server and execute it, which will consume cycles on the SQL Server. You have the result set on your local virtual machine, and you can just use the cycles and the CPU on your virtual machine or on your server. So it's much better to have it done like this. So let's suppose that we want to see the maximum for each column in this 1 hour period. If you want to see, this will be helpful because maybe you want to see the maximum for each when you are doing some troubleshooting. And you can see when exactly the maximum for a specific column was happened in which time interval. Okay, get the inflection points. Get inflection points is also useful when you have a huge result set and you want to see the rows which are very different than the row before or the row after. If you're gathering also data about, for example, this is a good example. If connection memory, if for our server 1D002 the connection memory kilobytes was 45,160 and the next value was 45,100, then it doesn't make if you want to chart it or to take it in consideration, because from the counter point of view the values were almost equal, which means you can ignore, and you want to not loop through 1000, 2000 rows to see the meaningful data. You want to see only the spikes. Only the spikes and the inflection points. So that's why I created this option. So let's suppose that we want to see for this column the inflection points. We will select the column and 5. This means it will start connection memory. We'll go back to the connection memory kilobytes 45,160. It will check if the next value 44,088 divided by 45,160 is bigger than 5, then the row will be displayed. After that, it will go to row number 3 and it will check if 43,792 divided by 44,088 is bigger than 5%, then it will display it. Since these values are very close to each other, we don't have rows return, which is why let's choose a column that has a huge variation between the values. For example, for this one, if we will execute it again, I can choose descending. We will have more rows because it will start with 13,000 granted workspace memory. It will start with this one, and this one it will be displayed because if we divide this by this, it's bigger than 5. But if we check 10,584 to 8,760, it will not be displayed because if you divide this, the number resulted is not bigger than 5. So that's why it is not displayed. The next one that will be displayed is 8,856. If you divide this by this, it's bigger. It will display. If you divide this by this, it's bigger. So that's why you display both rows, and if you divide this by this is bigger than 5, so you divide this 5112 and so on. As you can see here, the result set here is smaller than the result here above. The inflection point is something that also tools like Power BI is using when they have to excuse me, to chart the data that contains thousands of rows. For example, if you want to have an accurate chart about something, and Power BI cannot plot or cannot display in their charts thousands of points, because it will take consume resources, and it will take also a longer time whenever you are doing any operations like refreshing, filtering, or just resizing a chart, which is why they choose from the result set that comes. Sometimes they are choosing only a maximum of 3,000 rows that will fully describe the result set. That's why I wanted to have also this feature to get the inflection points from data result set in order to use it. For example, if I have to chart a very huge table which actually contains a lot of data which are duplicate. It doesn't make sense. For example, let's suppose that we want to create a chart for maximum workspace memory for that server, and it doesn't make sense for each collection time 9:30, 9:40 to put the same data. Maybe we can gather data every 5 seconds, so it doesn't make so. What will make sense is to see where the data is very differently, and after use that data to plot it. I don't know how clear it was, but this is what the inflection points does. Let's choose this column, memory grants outstanding. Let's see, because we have 2, 3, 5. Okay, let's see. 10. Memory grants outstanding. 5. 5, 5, 5. We start with 5. And after that, the next column, that the next value or row that is displayed, it's 1. Because 5 divided by 1, it's greater or equal with 5 descending the value here. So that's why it's displayed. This one and also this one. The next values, if we divide the 5 with 5 is not bigger than 5, 4 with 5, or 5 with 4 is not, 3 with 4, 4 with 3 is not, and so on and so on. So that's why those values are not displayed. Okay, the other feature that I want to explain here is union, intersect, except, and append. This is something that is useful if you execute scripts on different instances and you just want to merge the result sets. When I created this GUI for the first time, I was not able, or the feature to execute script against multiple servers was not implemented. So the only way in which I was joining the result sets was using this feature. For example, because we run separate databases for both databases, query trace file, get running traces. Get running traces was executed on DIMS MySQL Server 01, and it was executed also on the other trace file. Let's execute again. cp help db DIMS, okay, and a small result set, it's databases, separate databases. I want just a small result set in order to be easier to see what it does. Okay, we executed this for DIMS separate databases, and we'll execute this also for the other instance, MySQL Server 01, and we'll execute the script. Yes. We go back to the advanced feature, and we will load this last result sets, one to the left side, the other one to the right side, and let's suppose that we want to join this table to do the union. If I will click the union left with the right, we will see here we have 2019. So the results set are joined. If you want to see the databases which are on the same server and have the same sizes, for example, let's suppose that the server was built, and the server should have been built with model databases, MSDB databases with a specific side, and on the left side you have the template, and on the right side you have the server that was delivered, and you want to be sure that they match. You'll just check the intersect, and we'll say let's say right with left, but let's say left with right, and we can see that the master and the model are the same on both result sets, but DB here has a different size. So if it's not the same with the template, let's suppose that this was the template, you can quickly spot, and you can say, indeed we have this which is not according to the template. Also accept, you can see the accept information. Let's choose accept. We'll choose right with left. So on the right side we have these databases, and these databases don't exist on the left side. So this is good when you are trying to compare data and logins. For example, let's suppose that we want to see which logins exist on some servers and which logins doesn't exist on the other server. So I would just run script that will give me a list of logins and the databases on which they are mapped, and I will just perform the accept, intersect, or operations. Also, sometimes I want to join the values for specific columns as a string in order to paste it. I don't have a scenario in head right now, but sometimes we need this type of data in that format. So I just used here, for example, for this left result set, I want for the column remarks to join all the values under the database name column. So I'll just use like this, and I have the output. I can do the same here. I'll just select it for this to be the current result set against. I will do the work, and I will just select again remarks and the database name, and you can copy, paste it, and so on. You can use it further. You can use it further to do some other things if you want to share it or do some other things. Another feature that I put here was my selected value column. This is a feature that can be used with a specific result set. The result set needs to have at least one numeric column and at least one date time column. the perfect candidate for this type of for this feature is wait for delay. If we'll go for wait for delay and we will load it again to display the data, we will see here that we have the information stored for all the instances, for all the counters, and with the date stamp when those were collected. But let's suppose that you want to have this information displayed differently. So let's say transposed for each server. So I can choose this server and I will say make it column, and I can see the values for connection memory for this server for the dates. If I want to see what are the values for a specific counter for a different server, I will just select the server and I will say for this server I'm interested to see the granted workspace memory, and you will have it, and I will say make selected value column. I will choose make selected value column. It will use granted workspace memory, but let's suppose that for the server 10 \aha, I want to have information for a different column. You'll just choose the value here. And let's suppose that I want to see the information also for this. You'll select make it column, and if you want values for a different counter, you'll do it like this. And this is a different way to display the data from this table in other meaningful way. And because, for example, if you have a production server and a development server, and you are gathering data for both of them, and you have the process running, the same process or a similar process running on them, you can put them side by side and you can see, oh, it looks like for the production server we have in the time interval when the same process is running these values for these counters, while on the development or UAT server we have different values. If you have the data in the format like this, you cannot make those type of computations because it was not supposed. You cannot consume data in that form. That's why I added this feature here. Okay, another feature with the result set, it was this with retrieve counts. Retrieve counts. Count for selected cell from all the result sets. Okay, DIMS login. What I'm missing in SSMS, and I'm missing also in SQL in Azure Data Studio is the possibility, although that possibility exists, it's in a form that is not as easy to consume. I mean, Azure Data Studio Management, I don't know if it has that possibility. I can try to search it, but SSMS has this possibility, and for each result set, you can display them vertically or horizontally. Let me show you what I mean. CP databases, CP who. Okay, if you have new query, XP fixed drives, you can just a new vertical tab group, and you have the query and also the result set, and you can put also new vertical tab group. If I choose new query here, you move to the next, move all to the next, move to the previous, move all to the previous, and you can display the information like this. let's say move new vertical tab group. You can choose to have them horizontally or vertically, and sometimes this way of displaying the data is not um, suitable for it's suitable for maybe all the cases, but not suitable for your own specific case. Which is why I decided to create 12 result sets in which multiple scripts can be executed and data can be displayed. So if I'm going back here, choose 12 as an example, always on demo multiple results sets. So as you can see here, I have some selects, but you can replace these selects with other tsql scripts which will retrieve data from your instance. And if we execute this, maybe this was outdated, it's an old one. Diagnostic information. Let's see if I can use this one. Always on, not configured, so this is also not a good script to use. Let me see if I remember a script. 12 tables demo, 12 tables demo. Let's see if I can use this one. I cannot use this one because I am again on the old instance, and the proof of concept that I did were done with the tables that I created on the default instance. So let me switch back to the default instance and run this script again. Okay, the script was executed. Let's see the messages and errors. Invalid column name, job name, stem name, start date, and date, run duration, minute. And since I'm missing a table, I have this one with tsql. tsql code joins. I will just use this one. I remember I did in the past, and I posted on LinkedIn a proof of concept with this. So let me execute this one. So as you can see, I have I have the possibility to display multiple result sets in the same window, and this is more meaningful than the possibility or the way in which the SQL Server Management Studio does it. And if I wanted to increase the result set and to have more information about this, I can just increase this one and see all the columns, or to have more real estate for the result set for that specific one. This is useful, for example, when you have multiple tables in which you receive server build requests, you receive SQL login request creation, you receive database always on configuration, and so on. So in order to not have multiple scripts and multiple result sets return, you'll just return and see all the data in the same window. And if you need more real estate, you'll just increase the result set that you want. If we try to run to exemplify it, let me go back to take the script. So let me Control A, Control C. I will open SQL Server Management Studio. I'm connected. I will close all this. No. New query. I will paste it here and I will just execute it. as you can see, the output is in this format, and it's not easy to consume it. At least from my point of view, is not easy to consume, which is why I decided, okay, I will try to display it in multiple result sets, and I can also add some filtering or searching capability. Let's suppose that but this one is not but I can use it monitor and CPU. I see here that we have like values 5. Let's see that we are searching for value 5 here. Search dashboards 5. It displayed this, and let me see if I can search after monitor. Usually, in order to be faster, because these result sets can return hundreds of rows and maybe dozens of columns, the logic is to search only in the first or second column, and only if the column is numeric or and so on. So that's why. But let me search after the monitor. Okay, so we have monitor here. In the second result set, we don't have anything. In the third one, we have a monitor here, and the monitor, and so on. Okay, let's delete this. And we go back to the previous result set. So sometimes it's easier, and I'm a little bit disappointed that I cannot use this always on. Let me check always on. Always on. This is a script that I didn't create it, but I took it over from the internet. Now, if I am against the right instance, this script might work. Yeah, it's working. So you can see this is of course I don't have always on here, but only for showing this. I just created those tables, and I put the data there. So as you can see here, you can have information about always on, and you don't need to right click and opening multiple windows and going here and there to obtain this information. And there is another script on the internet which shows errors from always on, and you can always search after that error ID, and it will give you that information. Let's say, for example, here I can search about, I don't know, diagnostic information, diagnostic events, always on, execute. But this is the script that we executed, and we were told that always on is not configured. So yeah, I cannot show this, but I hope I made a point with the benefits that having multiple result sets displayed has over the displaying the same result sets like SSMS does. Let me see if there is something else related to result sets. Yes, there is something else related to the result sets, which is part of this chronology control. This chronology it allows me to search or to display the events in the time of their appearance. So, for example, I have this daytime column. Okay, I will choose the interval, retrieve data, non-date columns. I will retrieve the data. 312 start daytime. Retrieve data. running traces. Okay, this is not a good one because it has only a single row with a single timestamp. So let's suppose that I will retrieve the read error log, execute. I already have in the chronology so I will retrieve the read error log, and I already have the query trace files. So I will display this. I will choose the log date and retrieve the data. I'll choose the interval and I will choose retrieve the data. And if I'm choosing a different result set which contains also a datetime column and which rows are in this interval, those rows will appear here. So let's take this one, DIMS get running traces, retrieve data. T12 log on DIMS read error log. And so as you can see here, we have in get running traces between 4 p.m. to 4:12 p.m. we have this entry. And how this is how this is good. For example, let's suppose that somebody will do a backup of the database, or it will create a database. Then you can see the user and what they did on the server. Let's give an example. For example, I will just modify the server memory. Okay, memory, I'll just modify it from 200 megabytes to 210. Running values. Okay, I will just execute it, and let's suppose that every DBA is using a script which will search and display all the SQL Server configuration history. So I will just search after that script. And I will say get config change history. I will select it. I will execute it. I will go to the result set, and I will see this entry here. But let's go back to the chronology, and let's choose also. So we have get running traces, read error log, and let's also choose this configuration history, and let's retrieve the data. And now you can see, for example, the order in things were happening. This is good, for example, if you go to and retrieve the data from SQL Server error log, and you have always on, and you see information about the databases and how they switch from primary to secondary, or from synchronized to non-synchronized. And if you query also the default trace or a different DMV which holds information about the always on, or about the data that you are interested in, if you use the chronology, you will see the events happened chronologically, and this it's helping you to find a root cause or the order in which events occurred, and this gives you an insight on how SQL Server works, or how you should troubleshoot it. I'm trying to come up with a better example here, but I believe, yes, I believe I have an example. So let's suppose we have this scenario. I'll just reload the application. Okay, I'll close this window. I'll just open it again. And let's say I will run a new query. Cp help db. After which I receive a ticket or a task to create a login on this server. I'll just go to logins. I'll create a new login. AAA for server authentication and first no. Okay, the login was created, and let's suppose that tomorrow we as a DBA we are coming to work, and we have to troubleshoot, not to troubleshoot, but maybe to gain more information about who created that login. So for example, we can run now read error log, and query trace file. Execute. I should have, this is a related script, so actually let me stop it. That's why it shouldn't be executed like this. It should be executed get running traces. Okay, I will select I will select this, and I will go to related scripts and query trace files. Trace files. It's taking longer than it should. Anyway, okay, and now let's query also help login. Cp help logins. But of course, you can have a script which will select all from server underscore principals. And I believe that table or view has a column with the creation date of the login. But for the time being, let's suppose that this is enough: master, default, English, so on. So we are going to the chronology, and I know that read error log has a datetime column. I want to use this one. I'm choosing all the data from all the entries. I'm interested in all the entries from this, but I can choose if I'm supposed to search what was happening only between specific hours. And in our case, we know that we created the login 10 minutes ago. I'll just select here from 4:30, okay, to 5. I will retrieve the data, and I can see that the login was connected successfully. Let's check the query trace file, and start time. We'll choose the. I don't need to choose the start time. I will just say retrieve the data, and audit server, and here I will did audit add login event. So this is telling me that at 5:01 a login was created. I can see the logins which were just on the server almost at the same time. So you can see more information about this. So it gives you perspective of whom might have been creating this login and the order in which operations appeared. So, and here, if you roll over here, it will tell you what you will see on the right side as column 4, column 5, column 6, and so on. Are text data column, database name, database ID, entity domain, and so on. So this chronology has multiple purposes. Maybe I was not able to portray them as best as I could, but using the tool or using it at work, you will find the usage for this feature. Going back to the result set, let me see if I still have something that I want to describe. I believe for the time being I don't have. So thank you for your time, and see you to next video. Thanks a lot.